Hello, everyone, and welcome to week 4 of the Introduction to C# Programming live webinar class brought to you by 3dbuzz.com. So, our lead instructor, for those of you that are joining us for the first time, I know there's a few of you, is Mr. Nelson Lakay. Hello, Nelson.
Hello.
Hello. And myself, I'll be hanging out as well, Jason Busby. A lot of you guys know me as Buzz from over on 3dbuzz.com. And today, we're going to be talking about methods. And since I missed last week, I really missed you guys. Unfortunately, I was driving across the United States and was, well, unable to attend. So, Nelson, let's quickly, what did we talk about last week? And then we need to discuss some homework, and then we need to get into a nice lecture over methods today. And I do want to remind people, for those of you that may be joining us for the first time, since this is a relatively large class, nowhere near as massive as the first couple of weeks, it's still a pretty hefty size class. We will be doing all lecture in the first half of the class. For those of you that need to get to bed, get to work, or, well, do whatever you need to do. And then for those of you that want to hang out with us, we will then remain in the class and continue after that first hour is over. We'll stop the recording and we will open the floor for all questions. So if you are asking questions in the questions panel as the class progresses, please know that we're not ignoring you. We're just trying to get the lecture out first. Now, if we see something that comes across the questions panel that is critically important, or I feel is really important to get in at that very moment in time, I will have that question injected into the current lecture. But in most cases, we will be saving that for the second half. Now, we did have a very important question that just popped up right now saying, class is only 1 hour today. We try to keep our lecture portion to 1 hour, and then the Q&A could go for an hour, 2 hours. I mean, it really, at the end of the day, it comes down to the students. Those of you that are trying to learn, we are here for you. So as long as you're asking questions, we're not going to be closing the webinar down. We're going to continue answering and make sure that you feel comfortable with the knowledge you've been given. So hopefully that answers that question. So, Nelson, what did we talk about last week?
All right. So yesterday we went over arrays, lists,
Yesterday?
for loops, or yesterday. Wow. Last week we went over arrays, lists, for loops, for each loops, and switches. So yeah, we busted out the whiteboard, talked about what arrays are, how we use them, what they're used for, what their limitations are. Then we went into for loops, which allowed us to, well, clean up our loops quite a bit when we're doing common patterns of looping, which is what the for loop basically is. Then we talked about lists, which are collections that allow us to add and remove items dynamically, which isn't something that's possible to do with arrays in C#. Then we briefly talked about for each loops, which are even a simpler way of looping over items. And finally, we talked about switches.
Nice.
Which are basically just another syntax for a conditional.
So at this point, we have all of these cool means of storing data. We now have the ability to control flow, introduce more interesting logic. So with that, it's now time to start learning how to put our code into modules, if you will, breaking things up into methods. And that's going to allow a tremendous amount of flexibility in what we can code as we move forward. But go ahead, Nelson, and let's spend a minute talking about what the homework was at the end of last week.
Alrighty, so the homework was to build off of the existing program that we wrote in week 2 and modify it to be a little bit more dynamic and useful. So the idea is that we would use collections or lists specifically that will allow the user to actually input the inventory of the software before the program actually runs. So it gives us, it just makes the program a lot more interesting and dynamic. And whenever you're ready, Jason, I can go ahead and modify
Yes.
what I did last week and add in those elements.
Mm-hmm.
So if you guys recall, what we started with last week was a program that allows us to enter how much money we have and then allows us to purchase items. And then finally, when we run out of money, come on, seriously?
Why don't you just buy a bunch of Mountain Dews? I mean, they're $100, dude. All right. Anyways, continue.
But it finally just exits out of the program when you don't have any money.
Because you broke.
But to make this, Yeah, pretty much. You spent all your money on soda, which is hardly a good investment strategy. Um, so what we need to do now is we need to make the application more dynamic so we can input the inventory at the beginning of the program. So the first thing that we'll do is we'll add in some variables at the top of the program to contain the data that we need to contain. Because each item is both a name and a price, I'm going to put in two lists, two dynamic collections into the top of the program to contain the inventory. So the first list I'm going to introduce is going to be a string called product names, and of course I will have to instantiate it because that's what you have to do. We haven't really talked about instantiation yet. Now you'll notice the first thing that comes up is an error. That is because list is underneath the system collections generic namespace. So to make our code a little bit cleaner and easier to read, I'm going to add a using statement at the top of the program for using system collections generic. And that makes that error go away.
And as a quick reminder, people that may be coming in this week or may have been confused during last week's lecture, we just had a question come in saying, is a list like an array?
Well, yeah, a list is very similar in concept to an array, but it has the added benefit of being able to dynamically resize itself. And what I mean by that is you can have a list of 0 items, and then you can continuously add more items to it or remove items from it during your program's execution. Whereas an array, whenever you create an array, you have to specify a fixed size, and that array can never grow larger or smaller. But the reason we started out talking about arrays before we got into lists is that the concepts are the exact same. A list is just a way to store multiple of something, and that of something is defined right here by what's in these little angle brackets, in this case a string. So this variable, the single product names variable, is actually capable of storing 0 to many string variables within it. So now that we have our product names, I'm going to add in a list of decimals called product prices. And then I'm going to instantiate it. And why do we have to instantiate it? We have to instantiate it because I told you have to instantiate it. Again, we'll talk about that stuff in week 6. So the next thing we need to do is provide a prompt for the user to actually input product names and product prices so that these two variables get filled with data. So what I'm going to do is I'm going to create a while loop. I'm going to say while, let's see what we can do here. I'm actually going to introduce a Boolean. So I'm going to say Boolean is entering products equals true. And this Boolean will keep track of what state we are in the program. So what I can do now is I can say while is entering products, which is synonymous with while is entering products equals true, and then have this while loop execute its code repeatedly until I tell the program that is entering products is no longer true. So while we're entering products, we need a product name and a product price. So I'm going to say console write for product name or blank to stop entering products. Then I'm going to say item name, which is a variable I already have up here. If I put my keyboard cursor on item name, you'll see it on line 12. It gets highlighted, so we define it up here. So I'll say item name equals console read line. Then what I'm going to do is I'm going to say if item name equals blank, that means that we're no longer entering products. The user decided that, well, he's done entering products, and, well, we should exit the while loop. Otherwise, we have to get the item price from the user somehow. So what I can do here is I'm going to create another Boolean called has entered item price, set it to false, and then I'm going to create a, actually no, I don't need to create another decimal because I have an item price variable up here. And if you're thinking in your head, wow, these are a lot of variables you have to find up here now, so it's starting to look a little bit unwieldy, methods are a way of making that a lot cleaner, which we'll get into later. So I think this is a good example of how we can break up this code quite a bit. Okay, so now we have, inside of our else branch, we need to ask the user for an item price. So I'll go ahead and say console write how much does item name cost? Or enter item names price. That sounds like a better prompt to me. Then I'll go ahead and say while has entered item price is false, and we went over the bang shorthand last week, which the exclamation point just inverts the Boolean. What I mean by that is this code with the exclamation point is equivalent to if I had just done while has entered item price equals false. Or, yeah, stuff and things. So when I enter this while loop, I want to continuously prompt the user for the item price, which means I have to modify this a little bit. There we go. That looks a little bit clearer. That does not look a little bit clearer. Now it looks a little bit clearer. Okay, so we continuously enter this while loop, which repeatedly asks the user to enter the item price. And then what I'm going to do is I'm going to say has entered item price equals decimal.parse console readline, and then passing in this fancy little output parameter for item price. So what I want to do if they have entered the item price is I want to exit the while loop. Unfortunately, that's actually handled by a syntax error because we are running into a situation where is item price a decimal? It is a decimal. What am I doing wrong here? Blah, 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 blah. I forgot to say try parse. Thanks, Jason.
You're very welcome.
Okay, so this loop looks a little bit crazy, but if you follow the logic line by line, its behavior becomes a little bit more apparent. What we're doing here is we're setting the Boolean has entered item price to the result of trying to parse the decimal. So if we succeed in parsing the decimal, has entered item price becomes true. When has entered item price becomes true, the while loop exits. If has entered item price is false, that means the parse failed. And if the parse fails, that means they didn't enter a properly formatted input. So maybe they entered a string or something that isn't a decimal. And then it'll continuously prompt the user for the item's price. Once we have the item name and the item price, what I can do is I can say product names.add item name and product prices.add item price. So I'm simply adding the item name and the item price to these lists, which again, lists can resize dynamically, which means that these lists will grow in size so that they can handle all of the items that we're shoving into them. Okay, so basically what happens now is we have, at the end of this while loop, we will have a fully filled product inventory. Because remember that even after this else, once this else ends, it's going to enter this loop again. And is entering products is still going to be true unless the user typed in a blank string. So I know we're combining a lot of primitives together, and that's a very common theme in programming. When I say primitive, what I'm referring to is these very basic language constructs like whiles and ifs and elses and so on. And we're combining them together to create a more complicated product. And that's typically what you do in programming is you combine together whiles and ifs and expressions such as has entered item price equals blah together, you know, ad nauseum until your program does what you want it to do.
Now, I do want to bring this up, Nelson, and have you address it. We've got a few people that still may be a bit iffy on how lists work. And with knowing that, they're curious about, well, how do you know what price is associated with what product, since you've got these two pieces of data that are related but are being stored in two entirely different variables?
Sure. Lists are nice because they are ordered. Now, not every collection is ordered, but lists are. And that means that they behave just like arrays, in that every single unique value inside of this variable, this product names variable, is indexed to a particular number. That index starts at 0. So the first product names is at index 0. Every time as long as I add both of the names and prices at the same time, these lists will grow in size in the same way, meaning that I can use their index to associate the name with the price. So, for example, the first time this loop executes and we enter in a product name and a product price, the item name and the item price will be added to the product names and the product prices variable in such a way that they'll both share the same index of 0. The second time the while loop executes, when we add another item to both product names and product prices, that item will share the index of 1, and so on and so on. So we're associating the data by the nature of how lists work. And again, lists are ordered, so every single item that you add to it will be added at a particular index, and then the next item that you add will always be added to the index after that index, and so on and so on. Does that make sense?
Yeah. But now we also had another question to address real quick, and that is what happens if somebody enters a negative value for the price of an object?
The program will most likely, not once I run through my mind, it'll allow you to add add money to your wallet as you purchase items. It wasn't actually in the spec to validate number being negative. If you did put that validation in, that's a good thing to think forward with. I can go ahead and show the code for making sure that an item is not negative. But what if there's an item that's so horrible that someone put it in a vending machine? I can think of some examples from Japan that you actually give the user money when they accept it.
What?
I don't know. Okay, so what we could do instead is I can go ahead and say, okay, if item price is smaller than 0, smaller or equal to 0, because we don't want any 0 items in there either, what I can do is I can reset has entered item price to false, and then I can tell the user item price is not valid. Please enter price that is larger than 0. So does that make sense?
Well, yeah. Just keep
Okay.
cruising.
Okay, so
If you
at
if
the
you
end of
say
this,
if you say anything that I feel needs a lot more explanation, don't worry, I'll jump in.
okay, so once we've exited the while loop, our product name and product prices lists or collections will be full of the data that contain our inventory. The next thing that we have to figure out with this program is how to rewrite these bits to make it work with our new product inventory. So I'm going to skip this while loop because this while loop is going to work because we have a actually it's not going to work, and I'll tell you guys why right now. I believe never mind, it will work. I thought I reused the same variable, and as you guys can start seeing, knowing what variables you're reusing, how many variables there are at the top of the page, and so on, gets very confusing, which again brings us back to what we're going to be talking about today with methods. Okay, so no bit of the program needs alteration until we get to line 58. And this line ensures that you have enough money to purchase the least expensive item on the menu. So what I'm going to do is we need to turn this from a hard-coded integer literal into a expression that becomes evaluated. The easiest way to do that, I think, would be to keep track up here in our loop what the most expensive item is on the menu. So I'm going to, because we need to keep track of something, I'm going to introduce a variable. And I'm going to introduce a decimal called most expensive item. And I'm going to initialize it to 0. And then, before we add our name and price to our collections, I'm going to say if item price is larger than most expensive item, then I'm going to set most expensive item to item price. So we can do that calculation sort of inline in our program as we accept input from the user. But now that I have the most expensive item variable, I can go back down here to line 64 and I can say while money is greater or equal to most expensive item. The process of taking a hard-coded integer like that and replacing it with a bit of logic that is calculated at runtime is a very common thing you'll do in programming. So I just wanted to point that out real fast. Okay, so we have our line 64 working properly. Money has to be larger than the most expensive item. But now we have to replace this code right here. The prompt for the user is now incorrect because it's, well, hard-coded. So let's go ahead and nuke this and write a loop that will loop over our entire product inventory and display each item to the user. So I'm going to say for index equals 0. Index is smaller than product names dot count index increment. Then what I'm going to do is I'm going to say console.writeLine. I'm going to open up a square bracket because that's how, in a string, because that's how the input was presented before. I'm going to add in the index so the user knows what to type in order to get to the item that they want. Then I'm going to add in a space. Then I'm going to add in the product name. And I'll talk about this in a second. And I'll do a dash with the money sign, and I'll do product prices at I. So we have a couple things that is going on in this code that is very interesting, stuff that we talked about quite in depth last week. We have an example of a for loop. Again, if you have difficulty understanding a for loop, I put together a diagram last week that showed each one of the components of a for loop being rolled out into a while loop. So you can think of a for loop just as a while loop, but with a special syntax that allows us to write in shorthand. The next interesting thing is that we're retrieving how many items are in our inventory by using the count thing or property. And that is one of the most common things you will do with collections, because remember, the product names collection can grow or shrink in size during our program's execution. So we need to know exactly how many items are in our inventory to perform this loop. And we do that with the count property. The next interesting thing that we're doing is we are accessing data from within our collection, but we're accessing it in a way that we are indexing it by providing this index variable or this I variable inside of square brackets, and that just retrieves an item out of the collection that is at the specified index. So now that we have this prompt written, there's one more thing that is going to be slightly confusing to users, and that is this index variable, this I variable, is actually zero-based. You know it's zero-based because on line 68 I initialize I to 0. That's great for programming and programmers because a lot of languages, including C#, start at 0 for their indexes for arrays and lists. But that's not how most users think. So what I can do here is another thing that I showed last week where we can actually increment or add one to I in order to make it appear to the user as if the first item actually occurs on the index of 1. So just a nice little friendly thing for the user, and to make this consistent with the output of the previous program.
Now I know you're keeping this simple, but we did have a question come in that I think you might want to just point out real quick, and that is, shouldn't you have used, instead of most expensive item, perhaps least expensive item? Because, and you don't
How
have
did you let How did you let me? Well, yeah, I know. I know.
I was going to say you don't have to change that. You just, hey, if you can't afford the most expensive thing, get out of here.
Yeah.
It's okay. I just wanted to bring it to the attention.
Okay, so next up we we have our user input or user interface right here, and that's great. But we have one more problem, and that is when we retrieve or when we access our inventory to see if the user or what item the user has chosen, we do so right now in a hard-coded fashion. So we need to break out our menu choice variable or use it in such a way that we can actually access our items dynamically out of our collections. So to do that, the first thing I'm going to do is I'm going to nuke all of this code because this is all hard-coded. Actually, I'm going to keep one of them around just so I can remember which variables I'm actually altering. I'll delete that in a second. Or maybe just to make it clear that I'm not using this code, I'll comment it out. So what I'm going to do is we need to determine if the user input was valid. So I'm going to say if menu choice is greater than 0, and if menu choice is smaller or equal to product names.count, then set item price to product prices menu choice -1, and I'll talk about what's going on right here because it might look a little bit strange to people who aren't used to working with array indices or collection indices. And then I'll set is item valid item to true. So what's going on here is I need to make sure that the user has entered a menu choice that is within the inventory. So what I can do is the first thing I need to do is I need to make sure that they entered a positive value. In fact, I can go so far, well, no, this will work just fine because the positive value that I'm asking for has to be larger than 0. Because if you guys recall, I'm altering the output of the program to make it appear as if the inventory starts at item number 1. So 1 is the first valid item and is always going to be the first valid item for this program. So I'm making sure that they entered something that's greater than 0. Next step, I have to make sure that they've entered something that's within the bounds of the collection. You'll notice that I'm doing a less than or equal to here, not just a less than. And the reason I'm doing that is because menu choice, again, is 1 based. It starts at 1, whereas indexes for a collection start at 0. So the largest menu choice is always going to be the count of the items inside the collection. So if we have 3 items in the collection, then the largest menu choice is always going to be 3. But then when we actually go to retrieve the data out of our inventory, we have to modify our menu choice by subtracting 1 from it. And again, that's to compensate for the discrepancy between what we display to the user and how the data is actually stored in our program. Okay, so looking through the rest of this program, we should be pretty much good to go. Let's go ahead and run it and watch my computer explode.
Yay, fire.
Okay, enter product name. So I'll go ahead and do item 1, price is 30. Enter product name, item 2, and then I'll put in some garbage data. Or how about I put in some negative data or some 0 data and so on. So that's nice. So I'll give this an item price of 43. Item 3 has a price of 43. For some reason, item 4, 200. Then I'm going to stop this by hitting enter. And now it asks me how much money I have. And I'll go ahead and say, I don't know, 500. So it says you have $500. And I have 4 items. And you'll notice that their names and prices do line up because that's the way I had written this program. So now if I enter item 1, it says I purchased a item 1 for $30, blah, 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 and I can keep on doing this. Or I can go ahead and do
No,
an item.
Keep on doing that. But I can buy items.
Yeah. You're the one who told me not to fix it.
Well, you sounded like you were going to have an absolute heart attack, and I don't want you to have a heart attack in front of a lot of people, so I was trying to be nice. Gosh.
Okay, if you really want me to fix it, it's really very easy to fix.
It's very easy, yes.
But first thing I'm going to do is I'm going to say least expensive item, change the variable name. Then I'm going to say if item price is smaller than the least expensive item, then the least expensive item equals price. Finally, I'm going to change the while loop from most expensive item to least expensive item. Okay, so now if I run this program again, I can do item 1, 43, item 2. I don't know what's up with my hands hitting 43. Item 3, 453, item 4, blah, 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 item 5, item 6. So on and so on and so on. Then I can do blank. and then enter how much money you have. Let's put in 1,000. If I tried to buy item 4, it'll tell me you tried to purchase an item 4, but you do not have enough money. Then I can go ahead and let's say I want an item 6. Let's say I wanted an item 200. It says 200 is not a valid item. I could do this all day because we properly validate the user input. So then I can go ahead and try to buy, let's say, an item 6 again. So now we're at 295, or sorry, we're at 115, and let's go ahead and do an item 2 and an item 2, and I can no longer buy an item 2. So right now, the least expensive item that I can purchase. Did you let me fail again, Jason?
I would never let you fail, Nelson.
You always let me fail.
I do not.
If money, while money is greater than least if item price is less than least expensive item, least expensive item, blah, blah, blah. Comparison to less than or equal to, while money is, no, our money has to be greater than or equal to our least expensive item. Of course. Let's see if you're referenced anywhere. Nope, just there.
So,
never,
what is? I was going to give you a hint.
Yeah. Wow. How did you?
Well, I was about to give
See,
you a hint. I wasn't going to
see,
give it away.
last week.
I love watching you solve simple logic problems like this because you're so used to working with complicated stuff.
Yeah, well, see, the problem is that this method is just too large.
Oh,
It's
nice excuse. Yeah.
Well, it's true, and I can actually say that today because that's exactly what we're going to be doing.
Okay.
Um, so what I want to do is least expensive item, or if least expensive item is 0, then least expensive item equals item price. There we go. Derp. Can't believe you let me fail in front of so many people repeatedly, too.
We all thought it was cute.
You know, it didn't happen last week at all. Last week actually went rather smoothly. I think it's just because you're here. It's just making me confused. Okay, so now we have a program that actually works. Yes, your instructor is capable of writing simple software. Okay, so if I go ahead and buy an item 3, we no longer have enough money, and we can't purchase anything.
Very good.
Okay, so here's our program. How are you feeling about the implementation, Jason?
Yeah, it's fine. Did you not go over any logical operators?
Nope.
Okay, fair enough.
Okay, so again, we have a collection, and we use it to dynamically add items to our inventory. Then we present a user interface that's actually calculated dynamically by our software. And we calculate it dynamically by iterating over all of the items within our collections, which is going to be a very common thing that you do, again, iterating over collections, to present the user with their options. And then we do the opposite right here, where we retrieve what they selected through, again, other operations on our collections. So hopefully this is fairly similar to the applications that people had written for homework. And again, if people have any questions for this, definitely check out the forums or hang around until after class today, and we'll get to that.
Correct. Okay, fantastic. So now that we've had a little bit of fun with Nelson, and we've seen how the code should be implemented, or something along these lines to give us the functionality that we were looking for. Now, finally, let's move into something that's going to make Nelson much happier, and that's methods.
Alrighty. So methods. Okay, so let's go ahead and write out a simple application, console class program, static void main, blah, blah, blah. Okay, so in programming, you typically do repetitive things quite often. And what has been learned over the decades and decades and decades of programming languages existing is that you do repetitive things so often that they have introduced language constructs specifically for doing things that you might want to do over and over again. So what do I mean by that? Well, let's start off with a really simple example. Let's say I have um, let's say I want to present a user with the list or numbers from 1 to
Oh,
10,
good
and I want to.
heavens, man! Why you
Oh,
so? Look at it in the real world, ladies and gentlemen. We break things down into tasks that we know how to do. Here's a very important task to me, and that is making myself a cup of coffee. That's critically important. It's so important that everyone that comes and stays with me here at the Buzz Cave, they are taught how to make a cup of coffee because they must drink coffee with me if they're going to stay up all night. Now, we all know coffee is important. It's a task we must understand, and it's a task that does not require a lot of functionality in order to pull off. But as Nelson was just explaining a second ago, it is something that it's going to be repetitive, meaning, uh, well, I've had like 5 or 6 cups of coffee already today, and now my lovely Beaver Buzz energy drink. So I'm feeling pretty good for only having 2 hours of sleep. But the key thing is, if I wanted a cup of coffee, I could tell somebody here that knows the method of making a cup of coffee. I could say, hey, Meta, go get me a cup of coffee. And she's going to go into her own little world, basically. She's going to get up, she's going to walk into the kitchen, she's going to, fire up the coffee maker, make sure there's water in it, and blah, blah, blah. Next thing you know, there's a cup of coffee. See, I don't care. All I know is I called upon Meta to make me a cup of coffee. And I get a result back. I get a nice hot cup of coffee. So that is an analogy, a way of looking at what a method is, kind of in the real world, and it's a way of taking our code and breaking it up into smaller chunks that are handling a very specific task, and that's very important to understand because beginners in any programming language, writing functions or methods, will often write very long ones that will do multiple things. And what we want to do when we construct our methods is we want them to be as simplistic and handling a single task as possible. That's why that last homework assignment was driving Nelson crazy because it could have easily been broken up into a few methods to make the program a lot easier to read and understand and troubleshoot when there are problems. So that's what we're going to be taking a look at. How do we set up our code in a way that we have these little modules, these methods that perform specific tasks, and then we can call upon those methods to handle a task for us, and we can call upon those methods over and over and over if need be from a loop or from wherever, and that will make coding much more streamlined and, like I said a second ago, easier to understand and read and easier to troubleshoot. Hey, Nelson, you still there?
I'm still here.
All right, all right. Now you can go back to your. All right, in the world of programming, we're gonna do code and. Okay, so I'm sorry. Go ahead.
Well, yes, we are in the world of programming, and we are doing code.
Fine, just give me a hard time, man.
Um, okay, so Jason's already mentioned that we can use methods to acquire a result of some kind. So the
Do I make you nervous, Nelson?
the least method, or the most simple method that I can think of that will provide a use for users here and actually demonstrate something that could very much clean up our existing code base is the concept of retrieving or decimals from the user. And you'll notice that back on our program that we wrote before, we do that twice. We ask for the item price, and then we also ask for how much money that they have in their wallet. Now, again, a very common thing that we do in programming is identifying repetition and removing it. Like Jason said, when we introduce common functionality into these little things called methods, we make our program significantly more maintainable and easier to understand. We get a lot of expressive power out of methods, and we can also reduce the amount of code that we have to write. So I'll put up a quick example of, let's go ahead and do Boolean has entered decimal equals false, and then I can go and say while has entered decimal has not entered decimal. And I'll do decimal 1 equals 0. I'll say console right line enter decimal 1. Actually, how about right? That's better. Then I can say decimal 1 equals decimal dot triparse console dot readline out decimal 1. And what am I doing wrong again? Decimal 1 out decimal 1 decimal.
Oh, what does triparse return?
Why, Jason? Why?
I just told you. What does it return?
Why?
All right, I'll be quiet then.
Okay, so we have while not has enter decimal 1 has enter decimal equals triparse, blah blah blah. This is a pattern that we saw repeated at least twice in the last program, and we do it so often. So let's say we wanted to enter another decimal. So right now we have enter decimal 1, but we wanted the user to enter a second decimal for whatever reason. So the first thing we do is we introduce a new variable called decimal 2. Then we reset our has entered decimal to false, and then we take this code, we copy and paste it. We say enter decimal 2, and then we put in decimal 2 right there. And what if we wanted the user to enter 3 decimals? Well, copy and paste this code, insert a new decimal 3 equals 0, change the copy and pasted code by 2 characters, and we now have 3 decimals. And then let's do something interesting with the decimals. I'll go ahead and do decimal result equals 0, and then I can go ahead and say result equals decimal 1 plus decimal 2 plus decimal 3, and I can say console right line result equals result. So the thing about this program is it actually works, and it works the way we expect it to. I can enter invalid input, and I get kicked back to the prompt. I can go ahead and type in proper values if I wanted to, and I get my result. So although this is a completely valid program, we have a very horrible problem with it, and that is we have an example of massive amounts of code duplication. And the code duplication in this case is this while loop, and in cases other than the first while loop, this has entered decimal equals false. So we need a way to make this code a lot cleaner and easier to maintain. When I say easier to maintain, you can think of each one of these bits of code duplication as an additional place you have to modify your code if you want the behavior of retrieving decimals from the user to be changed. For example, if I wanted to prevent the user from entering a negative decimal or a decimal that equals 0, I would have to put that validation in 3 places. So we need a way to consolidate all this code into one single location. So what I'm going to do here is I'm actually going to go ahead and fire up a new project real fast. And then I'll go ahead and throw in a method. And I want to keep the old project around so that we can compare the two. Of course, I did actually keep that window open. Da 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 da.
So your wait music.
Visual Studio. Yes, that's my elevator music, you guys. Okay, so I'm just going to take this program and I'm going to paste it in. So we have this code duplication. How do we get rid of it? Well, we could actually tell Sharp to get rid of it on keystroke, but that's not the point. What I'm going to do is outside of main, and this is very important, I am entering code that is outside of main for the first time. So far, we've only played around with code inside of main, and then occasionally we'll throw in a new using declaration. But outside of main, what I'm going to do is I'm going to introduce a method.
But please,
and the
please
method,
take note that while outside of main, but still inside the
correct,
program class.
It still must be inside the class program. So you'll notice that the indentation makes that very easy for me to see that I'm still inside of the class program. So I'm going to go ahead and say static decimal get decimal from user string prompt. I know stuff is getting crazy right now. Then what I'm going to do is I'm going to write code that retrieves a decimal from the user, but it does so in a more generic way. Remember how we modified our program just now for homework that made the program from, sort of a more hard-coded fashion into a more dynamic fashion? Well, that's the same sort of process I'm about to go through. I want to take this code and generalize it so it can be reused from multiple spots within my program. So I'm going to say bool has entered decimal equals false. And you might be thinking, whoa, wait a sec. Don't you already have a has entered decimal variable? And that is definitely a question we will be answering. Then I'm going to enter a while loop that is pretty much going to look exactly like the while loop that we had before. Then I'm going to say console.write, and I'm going to pass in prompt. And you might be thinking, well, where's prompt coming from? Again, it's another thing that we're going to be talking about. Then I'm going to say has entered decimal equals decimal triparse, passing in console readline with a out result of decimal result. And then I'm going to throw another bit of crazy syntax at everyone. I'm going to say return decimal result. What I can do now is I can rewrite my program up here to be significantly cleaner. And watch this. And the program now works the exact same way as it did before. So just looking at this code, just comparing these two bits, you can already see a massive difference. And the massive difference is that we've significantly reduced the amount of code that we had to write because we've taken the repetitive code and we've placed it into what's called a method. What exactly is a method? Well, we've actually already been using one. Main is an example of a method. And all the same rules that we've been talking about with syntax and the different constructs you can use, such as for loops and collections and variables and all that stuff still applies to methods that are not main. When we declare a method, we have to do so within a class, just like we have to have main inside of a class. Again, what's a class? We'll talk about that in week 6. And it follows a very particular format of how we have to write our code that will look very familiar to what we see here on line 5. The first thing that we'll have to always use until we say otherwise is the keyword static. And the keyword static is something, again, we will be talking about in week 6. Unfortunately, a lot of what we talk about with methods sort of infringes on stuff that is better suited to be talked about in a dedicated class. So we'll skip static for now. The interesting bit is this. A method is made up of a couple things. The first thing it's made up of is its signature. And the signature defines a couple interesting aspects of the method that tell C# how it should be used or where it is appropriate to use this method. The first thing we have is the return type. Every method must have either a return type or a void return type. And the return, well, void technically is a return type, but again, what we need to do is we need to tell C# what data that this method is going to give back to us. A method that doesn't really give us data back or accept data in isn't a very useful method. If the method did not give us back a decimal, then it would be invalid to assign the result of this method into a decimal. So that's the first thing, it's the return type. The next thing is the name. The name is just like naming is for everything else in C#. It is up to you. There are rules that you have to follow when naming something. For example, it can't start with a number, blah, blah, blah. But the point is that we should give our method a name that describes what the method does. Not necessarily how it does it, but we need to say, okay, what exactly is our method going to do? And we need to give it a descriptive name so that ourselves and other developers can identify what that little bit of code is. Next up, we have our parameters. Now, parameters are nice because they allow us to change the way that our method works. They're all about being able to have a unique bit of data. You can think of these parameters as local variables, just like what we have up here in main, but that data is provided by whoever is responsible for invoking the method. And I know I haven't got to the invocation yet, but that's, again, I'm just going through this bit by bit, just throwing out words here and there, and it'll come back once we start walking through how the execution of this works. After we tell C# what our method expects us to pass into it, we have to open up a block. And again, this is where things should become a little familiar. I'm not expecting people to really understand methods or how to write them or being able to identify when you should use them, but I should expect that this block right here, it looks very similar to the block we've already been using with main, and that's exactly how it is. We have another block of code that contains a variety of statements within them, and those statements are executable, just like how main contains code that is run. But the important bit is that methods are not actually automatically run, unlike main. See, main is a special method. We've already talked about it being the entry point to our application, and that means that when the program starts, the first thing the computer is going to do is it's going to invoke every single line inside of main in sequence. And the computer knows what lines belong to main because they exist within this block. Methods that are not main will not be invoked automatically. They won't be invoked automatically by the computer at all. But the general principle of this method containing multiple lines of executable code is the exact same. And again, we can use the same stuff that we've been learning about with main for creating lists or looping over arrays and all that fun stuff. And we can do that within this. So then we enter some code. Now, the only interesting bit about the code I have highlighted right now.
Let's do something. Can we play for a minute, Nelson?
Sure.
All right. So put your cursor at the end of the line on line 30. Hit enter a couple times. And what I want to do is define a make coffee method. So you just go ahead and put this all into a multi-line comment. So let's just say that make coffee needs to return cup of coffee. Yeah. Now we need to give it a name for the method itself. And now nothing. And then whatever code, and you can just put a /line, single line comment inside that just to emphasize code here for creating coffee. There you go. So there's a method to, there you go, yep, good. Nice. So there's an example of a very simple method that has a return type and it does not take anything in. Now let's do one more method real quick. I want you to this one's going to be called make coffee with this.
With this?
Like, with these beans or with this, and you just give them something. I don't know. Just I want to demonstrate giving them something. So with this, and now take in, I guess take in coffee beans. There you go. And that's all. Just make fire. Here, stick, do. So here's another example of a method, but this method now is going to take something in. So it's expecting something. It's expecting coffee beans. That's a type. And then it's going to work with those coffee beans and return a cup of coffee that was, well, hopefully produced with those coffee beans. So there's two very simple methods, but just kind of tying this back to what I was talking about when we first started talking about methods 10 minutes ago, and in the real world, how we break things down into small tasks. And this task here is making coffee. If I was to call upon Meta to go make me a cup of coffee, she doesn't need to be given anything. But if I said, Meta, make me a cup of coffee with this, she's going to be expecting me to actually give her something that then she can go and put to use in making me a cup of coffee. So I just wanted to pull away from the example that Nelson was doing for just a moment and give this very simple demonstration for those of you that are completely new to the concept of methods, and hope you can see here a little bit clearer the part of the signature that talks about, all right, this is what we're going to return back. This is the name of the method itself. So this is how, well, when we need to invoke this method, we call upon this method. This is the name that we're going to use. And does the method actually require data to be passed to it? Or what happens if the method is a type of method that requires no data? And so you can see the differences with make coffee requiring no data to be passed to it, while make coffee with this requires a specific type of data to be passed to it. So hopefully that'll be helpful for some of you guys, and I'll hush up now and give it back to Nelson. Hey, all right, back to you.
Hey,
Hey.
so yeah, that's methods, or at least as far as their syntax goes, in kind of a nutshell. We have our return type and we have our parameters. Just like up here on line 18, we have a return type and we have parameters. This code right up here the code I have highlighted isn't particularly interesting. It does exactly what we did repetitively in this previous program. The only difference is that we use a prompt variable instead of hard coding the prompt into our code itself. That's the only difference. Other than that, you can take every, the existing perception you have about this code and use it, because it does the exact same thing. It's just C# code. Just because it appears in a different method doesn't mean it's going to behave any differently. So I won't talk too much about that quite yet, but what I do want to talk about is this statement right here on line 29. You might have noticed that I've used the word return multiple times already, and that was to describe the return type of the method. But specifying return type of the method isn't enough. We actually have to return data of some sort. We can't just say, oh, I return a decimal, because and if you don't actually return a decimal, then you're kind of lying. It doesn't make any sense. You need to, whenever you specify that you are going to give something back to the user, whether that be a cup of coffee or a decimal or a string or a product or whatever, when you tell C# that your method gives something back, you have to actually give something back during the course of the method, or actually you'll get an error. In fact, if I were to remove this line of code right here by commenting it out, you'll notice that little curly brace got squiglified. If I hover over it, it says return statement is missing. It's because we've lied to C#. So I want to enforce in everybody's mind a correlation between what we have right here with the return and what we have right here in the signature. And that, again, is the signature is the type of data we are giving back to whoever is invoking this. And then the return statement specifies the data that we're returning. Now, the interesting thing about a return statement is that a return statement will actually stop the execution of the method. What I mean by that is once a method has hit a return statement, it will exit out and go back to wherever it was. And that's a discussion we will definitely be talking about with the whiteboard a little bit later. But the important thing to realize about the signature of the method is the return type, the method name, the parameters, which I'll get a little bit more in depth in the parameters in a second. And then if we have a return type, we actually have to return the value back to the user or to wherever. So let's take a moment and look at what we actually did up here. We have 3 decimals that are being initialized to a method invocation. Now that again is a term we've been using over and over and over again since day one, is the concept of a method invocation. And we see examples of method invocations on line 14 and on line 15, where what we're doing is we're asking the computer to do something for us that main doesn't know how to do. Main doesn't know how to interact with the console or print stuff out. That's console's job. Main doesn't know how to retrieve a decimal from the user. That's the get decimal from user's job. So what we're doing here is, because get decimal from user has a return, because it has a return type that is filled with a value here on line 29, we can use it in expressions. And one of the most basic expressions that we have in C# is the assignment expression, which you see or 4 or 5 examples of in this code base. So the get decimal from user method, when we invoke it, will cause execution to jump from line 7 to 20. And again, that's something that is going to be a very difficult concept to grasp at first. But the most important thing to realize is that when we invoke it, and an invocation is characterized as a method name, get decimal from user is a method name. That's not an arbitrary name that I just pounded out right here. If I typed in whatever I wanted, I would get an error because that method doesn't exist. It has to be a method name that exists somewhere. And you can tell Visual Studio is actually highlighting every occurrence of this method name for us to make it a little bit clearer how this method name lines up with what we have here in the signature. Then a method invocation always has parentheses. Now we see examples of a method that has no parameters, but we still need the parentheses. And we also have already seen examples of methods that do have parameters. And when a method does have parameters, that means it needs data to work. And that data could be anything that the method asks for. In this case, the method is asking for a string. So you can kind of see this bit of code right here looks very similar to this bit of code up here. The difference is that this bit of code appears within a method itself and allows us to invoke the method or to ask the method to perform an action and give us back a result, and we are able to pass data into the method. The types of the data we pass into the method is determined by the parameter list. So a method isn't required to return anything, nor is it required to take anything in. But this is an example of a method that does both. And when it takes something in, we have to provide what are called parameters. A parameter is basically it looks just like a variable. You think of it like a local variable definition, just like what we have right here with decimal result equals 0. The difference is that the value of this variable is not calculated by the method itself. Instead, the value of this variable is calculated by whoever decides to invoke it. So what we can do here is, because this method requires a string as a parameter, we have to fill that string up with an argument whenever we invoke the method. We can fill the string parameter with any argument that turns into a string. In this case, I'm using string literals. We talked quite a bit about what literals are in week 2, but just to recap, I'm using a literal expression in C# that creates a value that is a string. And because this value is a string, we can fill it, or we can fill this parameter with that value. Okay, so I don't really expect people to to be able to go out and write methods left and right now. There are a lot of concerns about methods that we haven't talked quite about yet that are very important when working with creating applications that use them. But I think right about now, Jason,
You ready to pause and
I'm
take a
feel
real quick break?
yeah, because I'm feeling about jumping into the whiteboard, but I kind of want to step outside first.
Okay. Ladies and gentlemen, we have been going for over an hour straight now, so let us go ahead and take a 10-minute break. And I am recording this for those of you that were only able to hang out for an hour, and I'll be posting this up on 3D Buzz here in just a little while. But let's take about a 10-minute break, and then we'll start back and we'll continue with more lecture and go from there. So this is a great opportunity for you to get up, use the bathroom, grab some coffee, and yeah, all that good stuff. So I'm pausing video now. All right, ladies and gentlemen, we are now back from the break, and Nelson and I had this magnificent argument out on the front porch just a few minutes ago during the break about why start out teaching our beginners about methods using such complex methods, ones that take, arguments and have return types. So Nelson, do you want to take a minute and let's talk about baby methods? Let's build it up real quick, just for our complete beginners.
Sure. I mean, it is good to have sort of a bird's eye view of where we're going with this, but to make things a little bit simpler, I'm going to leave this project open,
Okay.
and I'm going to fire up another one, and I'm going to break down the syntax of methods just a little bit, and kind of get the concept of moving execution between methods sort of solidified, and then we'll move up from there, basically ending where we just started off with a more complicated / more useful method. But it's important to kind of get the syntax of methods down, and the concept, specifically the concept of how does execution run through your program. Okay, so I have static void main, and I might have something repetitive for some reason. I might do, or I might have a nice little hello world program, actually. It seems like a good place to start out. And I might be printing hello world multiple times. Well, let's see how we can do this with a method instead. Again, a method is just a way to package up a block of code that you can reuse throughout your program. At the simplest, most basic definition of the word, that's what a method is. Methods, again, take the static keyword for granted. We're not talking about that. Just always use it for now. And again, we have a return type, but in this case, ignore that bit because we are just having a void return type, which I'll define pretty soon here. Then we have a name. This is important. This is something that I want to talk about. Let's call this method say hello and open up some empty parentheses, which we won't be talking about. So the only bit of this bit right here on line 15 that's important at the moment is that we've given it a name. And what I can do inside of the method, or more specifically inside of the block that is opened because of the method definition, is I can place any arbitrary code that I wish. Again, not something that we've really talked about, or something we've already talked about, is that methods can contain just arbitrary code. But let's call this method hello world from method. Let's run this program. Well, you'll notice that it just says hello world, hello world, hello world, and hello world. Because I created a method, I've named a block of code. I've taken a block of code and I've given it a name, in this case, say hello. Just because I've done this, it doesn't mean that anything will happen. Remember, a method is just a packaged bit of named code that we can reference throughout our program.
Can we run it and prove it?
Well, yeah, I mean, I'm running it right now. The creation of a method does not actually impact our program whatsoever. What we must do is we must invoke the method. So what I'm going to do is I'm going to say hello, and I'm going to put this on top of every single right line. And then run this, and we get this output.
Now leave that.
What's going on?
Yeah, leave that up while you're explaining the flow of execution here.
Right. So what's going on is that. Oh, come on. Seriously, Visual Studio. You know, Display Fusion used to have this little button that said always on top. I like
you could
Fusion.
just like drag that back over and not worry about clicking. You just use your mouse to point. I mean, it is
I
a
could do
pointer.
that too. Yeah, it is a pointer, I suppose. Okay, so what do we have going on here? We have two things that are new for today. A method definition, which there is only one of, and we have method invocations, which there are now 4 of. A method invocation follows a particular syntax. And again, when learning syntax, you kind of have to take things for granted. You kind of have to think, okay, I'm learning a new language. This language has rules. What are the rules for invoking a method? Well, you have to identify the method, and I'll go ahead and click on that so we can see the relationship between these words. You have to identify the method by typing in its name. Then in this case, what we're doing is we're opening up and immediately closing parentheses, which the existence of these parentheses will become very, very self-evident shortly as we talk about what methods can do. Finally, because this is a line of code, we have to terminate it using the semicolon. So what happens when we have a method invocation? So this is a method invocation, but what happens when main hits one? Remember, program execution starts at main. It starts at line 6, and it'll end at line 20. Once we hit line 20, the program is done. But that's not to say that execution is constrained within main, because methods allow us to jump from one part in our code to another. So what's going on here is that on line 7, we have an example of a method invocation. Execution is going to jump from line 7 all the way to line 23 when the C# compiler sees that we have a method invocation. So on line 7, we start off just looking at line 7, and then we jump all the way to line 23 into this block. This block will follow the exact same rules as main, in that execution will start on line 23, continue for every single statement within this block, and then exit on line 25. Once the method exits, methods will always return to their caller. The caller of a method is simply the line of code that executed the method using a method invocation syntax, which again we see an example of here on line 7, 10, 13, and 16. So right now we have a method that has a single line of code in it. And I said that the method will behave like main in that it will sequentially execute lines of code until it's done. And I can prove that too by doing another console write line. Now watch what happens. Something crazy is going to happen. See? Watch when I hit F5. Boom. This second line of say hello is now printed 4 times. Why is it printed 4 times? Well, it's printed 4 times because we've invoked it 4 times. So again, on line 7, when we invoke say hello, we jump all the way to line 23. We execute every single line of code in sequence until we reach the end of the block. When we reach the end of the block, we go back up to the invocation. So let me rewrite main just slightly to give a better idea about how our invocations are working, as well as say hello. I'm just going to alter the strings that say hello does, and I'm going to put in just a little level of indentation. And then instead of saying hello world multiple times in main, I'm going to do this. I'm going to say console.writeLine invoking say hello, console writeLine ended. And then to make things a little bit cleaner, I'll do another write line right there. And I'll do this 4 times, just like we did before. Again, this code isn't any more complex than what we had before. We just kind of reorganized our write lines a little bit. And the reason I reorganized them is now when I hit F5, look at this. We can actually see a hierarchy starting to form. This hierarchy has 2 levels. It has main and it has say hello. So we see that in our output we invoke say hello. Then we jump our execution down to line 32. After line 32 we execute 33. So we see proof of that by the output being hello world, then the second line being printed. Then execution jumps from wherever the end of this is all the way back to where the method was invoked. Now this method's invoked from 4 places. I actually should have probably written this as invoking say hello for the first time.
How about just 1 and then 2 and then 3? I don't know.
Yeah, that's,
Quicker.
yeah, that's
faster.
probably better. Yeah, sure. But what we have right here is proof that our unique invocations of say hello are performed, and it happens 4 times. The important thing to understand right now is that say hello is defined once but is used 4 times. So even if methods are still kind of nebulous for some people, I really want people to sort of start to get the idea that methods are a way of packaging code. They're a way of saying that or defining reusable bits of code that we can execute multiple times, however many times we want, in fact, without having to redefine the method. So again, let's do another thing. I'm going to add a third line. By adding a third line was added to the output for every single invocation of say hello. By altering the code in one place, I've actually changed the output of the program drastically. And that is pretty much one of the big benefits of methods, is that we can centralize bits of key logic.
Now, let's do this before we begin talking about parameter lists and return types. Let's make sure that everybody sees and understands flow execution when you're looking at calls to multiple methods, meaning you've got a say hello. Let's create one more very simple method, maybe one that says say goodbye, and have say hello call say goodbye.
Right. Again, everything that can go in main can go in a method, and that includes invocations to other methods. So let's see an example of that. So what I'm going to do is we have say goodbye now. We've defined it. We've made it exist. We've made it exist because we told the C# compiler, I want a method called say goodbye, and this is what I want it to do. Let's add an invocation to say goodbye and to say hello and see what happens to our code. I'm going to add it at the right here. Add say goodbye. And you'll see that ReSharper totally messed up my syntax highlighting on console for some reason, but it still is valid. You see that what we have going on here is a nested invocation to another method. And we'll see an example of this method's execution starting on line 32, going to 33, going to 35, and then jumping all the way to 42, and then jumping all the way back to 37. So let's see that. Two things have happened. Again, I want to reiterate the fact that I altered the say hello method, which means that every single time say hello is invoked, that method becomes altered. But the second thing is to understand is the hierarchy of our application. And the hierarchy right now is that we have main. Again, main is always going to be the topmost method in your program. Or I don't mean topmost in the sense that has to appear right here. I mean topmost in that that's the method that the operating system runs. And then execution goes deeper when we tell it to. Like, for example, on line 8, we tell it to go into say hello. And then execution jumps down to line 32. We can see proof of that by the second line of being printed to the console is a hello world from method. Then we go ahead and do another line of write line, and then we jump into the say goodbye. So then now we're nested even deeper, where we have this goodbye being invoked from say hello. But execution, when say goodbye ends, when say goodbye reaches line 43, execution doesn't return to main. Execution returns to where it was invoked. And currently, the only place where say goodbye is invoked is right here on line 35. Now, that isn't to say that we couldn't invoke say goodbye from main. In fact, I could quite easily do that. Like down here, I could say goodbye, right here. Now what's going to happen? Well, our console output will look a little lopsided. But what I'm trying to say here is that we can invoke any method from any other method and do that as many times as we want to make a useful output to our program. In the case of say hello, yes, he does invoke say goodbye from within himself, but that isn't a requirement. We can invoke from however many methods we want in main in whatever order we wish.
So
So how is everyone
the
feeling?
biggest thing to keep in mind as far as following method calls and understanding where methods, once the method is finished with execution, where the program returns back to, just remember, execution always returns back to the guy who just called the method that executed.
Yeah, the keyword just called.
That's right.
Because say hello, when it gets executed from line 8, when it returns, execution doesn't return to line 23 or line 18 or even line 13. Execution will return to the specific invocation of say hello, which in this case is on line 8.
And we do have a very interesting question. Um, can you call main from inside another method?
Oh, sure. It's just a method. Hey, let's go ahead and call main from within say hello. So I just added an invocation of main. I know it's main because it's called main, which is the same name as what we have on line 5. I know it's an invocation because we open up a argument list, which we haven't defined yet, but keep in mind that's an argument list, and then we terminate it. But what happens when I hit F5 is this. Now eventually, we're going to get a Stack Overflow exception. But that's not important.
Actually, it's
Okay.
critically important, but we're not going to be discussing that at the
Yeah.
moment.
Yeah, it is very important, and you will probably, when writing methods, eventually you will probably cause a Stack Overflow. It happens to the best of us. Okay, so
Okay, so let's simplify your program now. Go ahead and put line 7 through 27. Well, actually, you can get line 27 now, but just simplify it all. Put it in a loop now, so that the top is just looping
right,
those 4 times.
so yeah, so instead of doing this in a hard-coded way, I can now enter a for loop. So I can say for int I equals 1, I is smaller or equal to 4, I plus plus. And then instead of saying invoking say hello 1, I want to make that dynamic. I want to say invoking say hello I. When I run this program, it's actually going to do the exact same thing that we did before. It's going to look the exact same. It's important to realize that pretty much every construct in C# when it comes to executable code, so I mean what I'm talking about are switches and if statements and while loops and for loops and method invocations, all that stuff can be nested and combined to create interesting results. So, yeah. Is there anything else you wanted to add before?
Nope. Now at this point, let's go ahead and introduce. So instead of saying say hello, let's introduce our first parameter and passing an argument. So let's have it say, we can just call it say, and then it takes in a string.
Sure. So I'm going to go ahead, I'm going to remove say goodbye from now and keep say hello around so we can take a look at it. Then what I'm going to do is I'm going to do a static void say string, I don't know, line, console write line, uh, okay, and then I'll jump out of the loop for now just to make things a little bit cleaner. And then maybe just to make things even more explicit. Explicit is good. I didn't say explicit, I said oh, I did. Wait, what? I think that could be taken in a completely horrible way, couldn't it?
Yeah.
Okay, so what we have right here is an example of a parameter. The wonderful things about parameters is that parameters allow us to change the behavior of a method and we can change the behavior of the method per invocation. Parameters are a really good way to make your methods reusable. What do I mean by that? Well, we have an invocation of say right here, and we're passing in hello world, but let's do another invocation of say. Let's say goodbye world, and say whoa and stuff, and so on. We can do this all day. And when I hit F5, what we get is the result of this method executing, but most importantly, the result of this method executing given a particular bit of data that we can change. Again, a parameter is what we have defined right here. The parameter here is defined in line 18. What we are saying is this method can accept input, and that input can change the behavior of this method. We're giving that input to this method with this syntax. The syntax is called the parameter list. And yes, because the parameter list is a list of things, it could contain multiple things, but we'll get to that. So what we have right here is what looks, again, like a local variable. This looks like a variable we're used to already writing in our main method. But it appears in a special place. Because it appears within these parentheses, it is a required bit of information that this method must receive in order to operate. By putting in a parameter, two things happen. The first thing that happens is that every time we invoke say, or the method that accepts the parameter, we must provide data that is in the exact same type as the parameter. So for example, if I said say decimal line, we would get a bunch of errors. If we looked at the error explicit, or looked at the error, it'd say argument of type string is not assignable to parameter type decimal. So we see here that the type really does matter. The type will determine what we have to pass in. It also alters the way that we can invoke this method. Again, I cannot invoke this method without providing a or an argument. Because if I hover over this squigglified code, it says method say is 1 parameters, but is invoked with 0 arguments. So that's the first thing that adding a parameter does. It makes it so that every time we invoke this method, we must provide a piece of data that is convertible to our type that we defined here. The second thing that happens is that this method now has a variable that we can use within it. Are you going to say something, Jason?
I actually missed unmuting him, unfortunately. But Jim Black had just made a comment over in questions panel if you want to read it. You don't have to read it out loud. And I was about to, I have no idea what he was talking about. I was about to unmute him and have him explain, but he seems to have jumped off. But anyways, do you have any clue what he's talking about?
No.
Yeah. Well, perhaps at some point he will jump back on, and then I can just unmute him and he can actually explain himself, which would be fantastic. Otherwise, I just have to assume he was just being an asshole. Okay, continue.
Alrighty, so, yeah. So what we have going on here, again, the first thing is that by providing a parameter in our parameter list, we must provide that data. The second thing is that that method now has access to that data that is named in the same way that our parameter is. In fact, if I click on it, I do this a lot just to show people that things aren't magic. The names that I use in this program are very specific, in so much as in order to access this data, we must use the same name as the parameter that we called it. In this case, we call the parameter line. Therefore, there is now a variable inside of this method that has the name of line and the type of string. In fact, if I mouse over it, it says parameter string line. So again, a parameter allows us to alter how our method works. But we can alter how our method works from the invocation, which makes our methods a lot more reusable. So for example, let's say I wanted to let's introduce, unless there's anything else you wanted to add, I want to go ahead and introduce a method with multiple parameters, so that's okay.
Mm-hmm.
Okay, so I've done something a little crazy here. Again, when I talked about this part of the signature, I said this was a parameter list, which means that it can contain 0 to many parameters. What we have here is an example of a method that has 2 parameters, one integer called left and another integer called right. So we can add as many parameters as we wish to our method. In this case, what our method does is it computes the result of adding left and right, and it prints it out to the screen. So what I can do now is I can say AddNumbers, and I can invoke it. But because this method requires 2 parameters, I have to supply 2 arguments. Remember, an argument is the data that we're giving to the method from the call site, or from where it's invoked from. In this case, line 7. So what I can do is I can do AddNumbers 1 and 1. To separate arguments, we just separate them with commas. And I can go ahead and do AddNumbers 2 and 5 and 10 and 13, or how about 132? I have fat fingers. And then we go ahead and hit F5, and what do we get? We get the result of invoking AddNumbers 3 times, but the important thing to take away from this is that we're invoking AddNumbers with 3 different sets of arguments, which again gives us a great amount of flexibility. It allows us to accept data that can alter the behavior of our method depending on what exactly we want the program to do. So, yeah. How's everyone feeling?
We're all feeling great, Nelson. Thank you very much, sir. You can keep going. I love it.
Oh wow, yeah, they seem quite enthusiastic.
What was
That's awesome.
that?
It's a class, man. They're all sorts of happy.
Hurt my brain.
Other than Jim Black, who says you are overcomplicating the simple. But I think you're doing great, sir.
All right. So we did get a question that I did already answer. You cannot invoke a method unless you provide an argument for every single parameter in it, and those arguments must match the exact same type. Okay, so that's an example of a method that does something given data. But methods can actually do more than that. And very, very commonly, we don't want a method to necessarily do something on our behalf. Instead, we want a method to perform an operation and allow us to decide how we want to deal with the result. For example, AddNumbers currently prints out to the console. Imagine for a moment that addition was a very, very complicated algorithm that required hundreds and hundreds of lines of code. And at the end of this addition, all we do is we print out the result to the user. That might seem pretty good right now. That's what we want. But what if we wanted to take the result of doing this very complicated 100-line addition and we wanted to do something else with it? What if we wanted to do something else with it depending on where we're calling it from? Maybe in one case we want to print it to the user, and in another case we want to write it to a file or send it over a network or something like that. We want to be in control of how the result of AddNumbers gets back to the user. So what I'm going to do is I'm going to remove the output from here. We no longer want the output to be inside of our method. Instead, I need to find a way to give the result of AddNumbers back to the user. We do this with returns. Now, this code won't work yet, but what we have here is an example of us telling C# that we want this data to be given back to whoever invoked this method. And whoever invoked this method is then going to be responsible for taking this data and doing something with it, which makes our method a lot more flexible. But unfortunately, or fortunately, C# is a static language and it's important to do this, we need to tell C# preemptively exactly what kind of data this method is going to give back. We can't just say return results. Now, this would be valid in some languages, particularly dynamic ones, but with C# we have to actually tell the compiler up front what kind of data it is that this method is going to give back to the user, or to the programmer who invoked this method. We do that with the return type. The return type is right here, and it's void. Void is a special keyword in C# that pretty much means nothing. By specifying the return type as void, I'm saying this method does or does not return a single thing. In fact, I can see an example of this by trying to do something with the invocation of AddNumbers. I could go ahead and say int result equals AddNumbers, and I'll get an error up here too. I get an error saying that you can't convert a void to an int because this method returns a void, which is nothing. So instead what we have to do is we have to tell the C# compiler that we want to return data. And because C# is a statically typed language, which means that we have to be explicit about our types. We have to, a variable can't be an integer and a float. It has to be one or the other. Same thing's true with return types. We must explicitly say that this method returns, an integer. By changing the return type to integer, two things happen. The first thing that happens is that we are now not only allowed to return a result, but we are required to. If I did not have this return statement here, this method won't actually compile. Take a look at this squiglified curly. It says return statement is missing. So we have to return a result, and the result has to be the same type or convertible implicitly to the same type as the return value, or the return type, that we defined here in line 15. The second thing that happens, the most interesting thing that happens in my opinion, is that we are now allowed to invoke the method and have its data be stored in a variable, or in fact, if we wanted to get all crazy, we could have this be nested really deep in an expression, but that makes things a little bit more difficult to read. What we're doing now is we are storing the result of AddNumbers into the result variable. So what I can do is I can go ahead and say int result2 equals blah, int result3 equals blah. I can do this all day. And when I run this program, what's going to happen? Well, nothing. Nothing's going to happen because there is no output in this program anymore. The only console input-output that we're doing is this console read key, and that's not going to affect anything. That just pauses the console. So what we've done is conceptually very important. We have made it so that AddNumbers is no longer responsible for printing itself. But unfortunately, we've also made it by doing that, we've made it the responsibility of main to do something with the result. So now what I can do is I can say console writeLine result equals result. And then I can do 2 and 3 and 2 and 3. So now main has the responsibility of doing something with the result. And again, this makes the method more complicated because if we had 100 lines of code in AddNumbers, we might want to reuse this result for different purposes. Sometimes we might want to print out to the console. Sometimes we might want to print out to the a file. And so now when I hit F5, we get our results printed out again. So is that making sense a little bit?
Yeah, Nelson, that's great. That made a lot of sense to me. Can you actually use those methods like inline? Like if you wanted to, like line 13 console.writeLine and put it in line?
Yes, you can, Jason.
I don't know what you're talking about.
Um, yeah, the invocation of a method is returns a value, which means that you can use an invocation of a method anywhere where a value is accepted, which includes concatenation or anything else that you might want to do. So again, this program has the exact same output as it did before. The difference is that it's a bit cleaner because we're no longer aliasing out the result of this method invocation into a variable.
The cool thing is, though, is that you guys have now seen through a progression of different methods that Nelson has been using over the last 25 minutes. You guys have seen very simple methods that take in no arguments and have no return type. You've seen methods that have no return type, but they take in arguments, and you have seen methods now that take in data and return data. So this is a much simpler approach to kind of wrapping your head around how methods work and how you define them and specify if they're going to take data in and if they're going to return data back to the caller, than jumping into something a bit more crazy. Yeah, Nelson, all right. So let's move on. You hate me being back
Alrighty.
in town, don't you?
No,
You're
no,
just
no,
like,
no, it's good.
I can't wait for him to leave again.
Um, yeah.
Is this? Oh, go ahead.
You what? Is this what?
Well, I was going to say, all right. So now you've gone through methods. There was a question that came up several times with people asking about, can we return multiple things back?
No. A return value is called a return value, not a return list, for a reason. A return value may only return a single thing. Now, that thing can be anything you want. And when we get into week 6, you will see, or you'll find a very easy way to mimic the behavior of returning multiple items. But you're actually not returning multiple items. You can't do that in C#. It would be very, very confusing. So now that I'm jumping back into, where are you? Here you are. Hopefully the code that we have here is starting to make a little bit more sense. Where we have an example of a method that not only does it accept input, but it also produces a result. And that result is of type decimal. So we see an example of the method definition down here. We also have 3 examples of the method invocation. In each one of the method invocations, not only do we store the result of those unique method invocations into different variables so that we can use them later, but we also provide 3 unique sets of input into the method so that it behaves slightly differently every time it's invoked. So again, we have interdecimal 1. When I receive this input, that input isn't coming from this string right here. This string is being threaded into this method through the prompt parameter and being written out to the console by line 25. Same with decimal 2, same with decimal 3. So hopefully people are getting a better idea of what's going on here. Now, there are a couple of important, slightly more advanced things
Actually,
about...
before we get to more advanced things, there was a question that was asked earlier. I think this would be a good time to make sure that it is addressed. And that is in regards to naming conventions with C#, with how you should capitalize.
Well, like any identifier, and I say the word identifier a lot. An identifier is a special concept within programming languages. With any identifier, including stuff like program and my local variables and even my methods, they all follow the same restrictions of naming. For example, if I wanted to,
I think you've made your point.
this is a completely valid identifier name.
And you, sir, are an idiot. Oh, sorry.
Well, and I can use this identifier name for any identifier in my program. So I can even name my local variables that if I wanted to. But obviously we don't do that. Although every identifier follows the same restrictions, there are special rules depending on what kind of identifier we're talking about that make your program consistent with the way the language is intended to be written. So we already saw examples, or we've already seen examples of local variables. And local variables start with a lowercase, and every word is delineated by an uppercase character. So that's camel casing. But with method names, we have a different naming convention. Method names should always start with an uppercase, and that's just how it is. You can see examples of methods. We've already been invoking methods quite a bit throughout this class, and every method that we've invoked follows this convention. For example, look at WriteLine. WriteLine is a method, and look at its naming. It starts with a capital W, and then the second word in it is delineated by an uppercase character. Same with readKey. Starts with an uppercase character, and then every subsequent word is delineated by an uppercase character. So that is the naming convention for C#, and you just follow it. I mean, I understand for beginners, it might seem kind of arbitrary to follow these sort of rules, but I can absolutely guarantee you that this is a vital aspect of programming that shouldn't be taken lightly. You should get in the habit right now of following the standard C# conventions, with the exception of private fields, but we haven't talked about private fields yet. But when it comes to things like method naming and local variable naming, that's what you should do.
Okay, so is that pretty much everything that you had planned in regards to an introduction to methods today?
Well, there is one more thing that I wanted to talk about. Depends on if you're trying to kick me off or not.
No, what's that?
I did want to bring up the concept of scoping real quickly.
Okay. Yes.
Not like a whiteboarded out stack frame, but just a basic overview, because this is something that people will get confused about. I've seen them get confused about it, and I think that I can cover most of the confusion with just a quick overview of what I mean by scoping. So, to put it simply, every method has a scope. Now, more things have scopes than just methods, but we're just talking about methods. So far, we've just been defining our variables at the top of our methods, and I encourage people to continue that practice until they get a lot more comfortable with the idea of scope. A scope basically is a grouping of identifiers, or variables, you could say, meaning that a variable within scope A is not going to be accessible from scope B. So again, there are multiple ways to define scopes. For example, technically while enters new scope 2. But I'll include that statement for the sake of completeness, but for the sake of what I'm talking about right now, let's just say that this program has two scopes. It has a scope that starts on line 19 and ends on line 30, and it has a scope that started on line 6 and ends on line 16. Because these are in two separate scopes that are in no way related, nothing inside of either method can access local variables inside either method. So let's introduce a third scope. I'm going to say static void scope example. Now, what if I want to do console WriteLine decimal 1, and then let's invoke scope example in main. I'll move this up here. Okay, so we're invoking scope example on line 12, and this method It's trying to access decimal 1, but you'll notice it's actually an error. If I try to run this program, I'll get a compiler error saying that the name decimal 1 does not exist in the current context. That is because decimal 1 is defined in a scope that is not related to line 20's scope. And there's no way for you to be able to access decimal 1. But what if I really, really, really wanted decimal 1? Like, it was vital to my program's execution that scope example printed out the value of decimal 1. Well, you would use parameters. So I can do decimal, or my decimal, and I can change that to that, and then I can pass in decimal 1 from here. Now the code works. Remember, wherever your local variable is defined, that tells the C# compiler which scope owns it. Decimal 1 is owned by main, and the only way for the value of decimal 1 to get moved to another scope is through the use of parameters. Or, well, arguments, but yeah.
And it's
So,
not that it's getting moved, it's a copy of that data.
It's getting copied. The value is getting copied and pushed down into scope example, the method scope example. So again, this is the kind of the number one stumbling block that I see with people writing methods is they try to pass information around and they kind of think that, well, you know, I'm so used to referencing my local variables, but when you have methods, you can't do that. And this isn't an arbitrary restriction that C# enforces on developers for no reason. There are highly technical and important reasons why this is the way it is. So just keep that in mind. Ready?
Yeah. Okay, so are we ready to go ahead and take a break, wrap this up as the lecture, and then after the break, come back for those that are left, start interacting, answering some questions? Was that a uh-huh?
Yeah,
okay.
That was but for some reason my voice cut out for a second.
Gotcha. All right, ladies and gentlemen, that is going to wrap up week 4 of the Introduction to C# class. So I will have this video posted online on 3D Buzz here in just a couple of hours. We're going to take a 10-minute break, and then for those of you that have questions, hang around. After the break, we will be more than happy to answer them. So we'll go ahead and end the video here. Thanks a lot, everyone, and goodbye.